Okay, students, let's get started with the MCQs of AS Physics, Work Energy Power. Let's start with the first MCQ. A wooden cylinder floats partially submerged in a bath of water. A force F is applied to the cylinder until it is just fully submerged. Perfect. Which statement is not correct? Okay, we have to tell which statement is not correct. Some of the water gains gravitation potential energy. This is correct. Why? Because some of the water that might have been here at the bottom edge must have moved to the top. This causes the water to gain gravitational potential energy. Yeah, that's correct. The cylinder loses gravitational potential energy. That is also correct. Work is done by force F on the cylinder. Yeah, that's also correct. Option D, work is done by upthrust on the cylinder. No, that's incorrect. Upthrust is just a force acting like this on the top side. This does no work on the cylinder. D is incorrect. Let's further move ahead. A builder holding a brick of mass 3000 grams, okay, drops the brick on his foot. What is the reasonable estimate of the change in gravitational potential energy of the brick? Perfect. So the brick is basically of 3 kg. Perfect. G is 9.81 ms minus 2. And what could be the approximate height of a person? What could be the approximate height of a person? Let's say 1.5. Let's say 1.5. So change in gravitational potential energy will be what? mgh. What is m? 3. What is g? 9.81. And let's say h is 1.5. 3 into 9.81 into 1.5. This comes out to be 44 joules rounded off. A is your answer. And if you check in the marking scheme, A is your answer. Simple. Let's further move ahead. Okay, let's see this. A projectile of mass 0.25 kg is at a height of 30 meter above horizontal ground and is traveling at 15 ms minus 1. Perfect. At a short time later, the height is this and it is traveling at a velocity of 5 ms minus 1. Perfect. How much work is done against air resistance during this time? Perfect. So there are two positions. At one position, what is the total energy? Let's say this entire thing is your position A. And let's say the last one is your position B. This entire thing is your position B. Let's first of all calculate the total energy at A. The total energy at A will be equal to what? Gravitational potential energy at A plus the kinetic energy at A. Okay. What is the gravitational potential energy at A? 0.25 into G, that is 9.81, into the height, that is 30, plus the kinetic energy 1 upon 2 into 0.25 into what is the velocity? 15 square. Okay. What does the total energy at A come out to be? 0.25 into 9.81 into 30 plus 1 over 2 into 0.25 into 15 you can say square. The total energy comes out to be 101.7 joules at point A. Now let's calculate the total energy at point B. Let's calculate the total energy at point B. The total energy at point B will be equal to what? Gravitational potential energy at point B plus kinetic energy at point B. Let's do it. What will be the gravitational potential energy at B? 0.25 into 9.81 into the height, that is 35, plus the kinetic energy, that is 1 upon 2 into 0.25 into 5 square. Let's calculate this. 0.25 into 9.81 into 35 plus 0.25 into 5 square divided by 2. This gives you an answer of 88 point, you can say, yeah, 96 joules. Perfect. Let's do it accurately. Can you calculate the difference in energy? The difference in energy will be your work done against air resistance. 101.7 minus 88.96. What does your difference in energy comes out to be? 101 point 0.7 minus answer. Your difference in energy is roughly 13 joules. B is your answer. Let's further move ahead. A lamp is switched on for 2 hours. The power input to the lamp is this. The energy given out by the lamp is this. Perfect. How much energy is converted to other forms by the lamp? Perfect. Okay. So the lamp is switched on for 2 hours. The power input is this. Can you calculate the energy input? Yes. Energy input is equals to power input into time. What is the power input? 1. What is the time? 2 hours. 2 into 60 minutes into 60 seconds in each minute. What is the energy input here? The energy input here is 7200 joules. Perfect. Only 7.0 into 10 raised to the power of 3 joules is converted into light. How much energy is converted into other forms? Subtract it. 7200 minus 7 into 10 raised to the power of 3. 200 joules comes out to be your answer. B is your answer. Which question is this? This is question number 5. If you check in the marking scheme, 5 has an answer of B. Perfect. Let's move ahead. Let's see this. A box slides down a rough ramp. Okay. The change in gravitational potential energy of the block is 16 joules as it moves between position X and Y. The box has 14 joules of kinetic energy at X and 35 joules of kinetic energy at Y. Perfect. How much work is done against friction? Very, very easy. The change in gravitational potential energy from X to Y, or you can say the loss in gravitational potential energy from X to Y is 16 joules. What is the gain in kinetic energy? The gain in kinetic energy is what? From 24 to 35, that is 11 joules. Where does the remaining 5 joule go? See, there is a loss of 16 joules. 11 joules is gained by kinetic energy. Where does the remaining 5 joule go? The remaining 5 joule is turned into work done against friction. This question is 7. The answer to 7 in the marking scheme is A. You are correct. Okay, so a spring is neither initially neither compressed nor extended. A force can be applied to this spring so that it is either compressed to a shorter length or extended to a longer length. What is the change in elastic potential energy in the spring when it is extended and when it is compressed? Okay. What will be the change in elastic potential energy when the spring is extended? It increases. What will be the change in elastic potential energy when the spring is compressed? It also increases. D is your answer. Either you compress or extend your spring, your elastic potential energy increases. Please remember this. This is a common misconception that students have. Okay, let's see this question. A trolley runs from P to Q along a track. At Q, its potential energy is 50 kilojoule less than at P. Okay, so at Q, or as we go from P to Q, the loss in gravitational potential energy is 50 kilojoules. Perfect. At P, the kinetic energy is 5 kilojoules. Perfect. Between P and Q, the trolley does 10 kilojoules of work done against friction. Perfect. What is the kinetic energy of the trolley at Q? Okay. So if you are losing 50 kilojoules of energy from P to Q in terms of gravitational potential, you are giving 10 kilojoules to friction. 10 kilojoules is given to friction. What is the gain in kinetic energy? The gain in kinetic energy is the remaining value, that is 40 kilojoules. 40 kilojoules is the gain in kinetic energy. The kinetic energy was initially 5. So 40 plus 5, this becomes what? 45 kilojoules. B is your answer. Simple as that. Let's further move ahead. A trolley starts from rest at X. Okay. It rolls down to Y and eventually comes to rest at Z. Perfect. Which row is a possible summary of the energy changes during this process? At X, you are at rest, so your kinetic energy is 0. All of it is gravitational potential energy. At Y, your height is 0. So your gravitational potential energy is 0. All of it is kinetic energy here. And at Z, again your velocity is 0, hence your kinetic energy is 0. All of it is gravitational potential energy here. So what is happening actually? From x to y, your gravitational potential energy gets converted into kinetic energy. There is one more thing missing here. Due to friction, there will be some amount of heat as well. So either C or D will be your option. As you go from Y to Z, your kinetic energy gets converted into gravitational potential energy. You are again forgetting one more thing. There will be some amount of heat here as well. Which option is correct? Option D is the correct answer here. Okay, let's see this. A car of mass 500 kg is at rest at point X on a slope perfect as shown. The car's brakes are released and the car rolls down the slope with its engine switched off. Okay, so there is no force from the engine and the mass of the car is 500 kg. Perfect. At point Y, the car has moved a vertical height of 30 meters. Perfect. And has a speed of 11. Perfect. What is the energy dissipated by frictional forces when the car moves from X to Y? Okay. So from X to Y, what is the loss in gravitational potential energy? From X to Y, what is the loss in gravitational potential energy? Pretty easy. mgh. What is the mass of the car? 500. What is g? 9.81. What is the loss in height? That is 30, I guess. Yes. Can you calculate the loss in gravitational potential energy? Yes. Into 30. This gives you a value of 147,150 joules. Perfect. From X to Y. From X to Y. Can you calculate the gain in kinetic energy? Yes. The gain in kinetic energy is what? Initially it was at rest, now it is at a speed of 11. 1 upon 2 into mass, that is 500, into velocity square, that is 11 square. 250 into 11 square, this gives you an answer of what? 30,250 joules. Subtract both of that. 147,150 minus answer. This comes out to be what? The work done against frictional forces comes out to be what? If you minus both of them, 147,150 minus 30250, which comes out to be 116,900 joules. Any options like that? B is your answer. Let me check it as well. The answer for 15 should be B. 1 second. Yeah, the answer for 15 is B. Perfect. Let's move ahead. Let's see. The battery of a small tablet computer is initially uncharged. Perfect. It is connected to a constant power 10 volts supply for 2 hours to charge the battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? Okay. You have to calculate the total energy stored in the battery. First of all, can you calculate the energy input? Yes. Power, that is 10 volts multiplied by the time, that is 2 hours. 2 into 60 into 60. This comes out to be what? 10 into 2 into 60 into 60. This comes out to be what? 72,000 joules. Perfect. This is your energy input. Okay. You have to calculate the energy output or the energy stored in the battery. How will you do that? Efficiency is equals to energy output divided by energy input multiplied by 100. If your efficiency is 80 divided by 100, energy output is E naught, energy input is 72,000 joules. So zero point 0.8 into answer, this will give you an answer of what? Energy output is 57600 joules. Okay, what will be your answer here? Your answer here can be C. Let me check. The answer on the marking scheme is also C. Perfectly fine. We are going good. Okay, let's see this question. An electric car travels at a constant speed of 70 km per hour for 80 kilometers on a straight horizontal road and uses energy E from its battery. The total resistive force acting on the car is directly proportional to speed. Okay. So the resistive force is directly proportional to speed. Perfect. Assume that the electric motor is 100% efficient. How much energy is used from the battery when the car travels at a constant speed of 60 km per hour for 80 kilometers on a straight horizontal road? Perfect. So first of all, can we remove this direct proportionality sign? Yes. And there will come a constant k, v square. When the velocity is 70, what is the value of k? K is equals to 70. Okay, F over 4900 is equals to your K. Perfect. Now, let's calculate the energy. Let's calculate the energy for what? When you have 60 kilometer per hour, F is equals to kV square. F is equals to K is the value of what? F over 4900 into what? 60 square. This becomes what? 60 square divided by 4900. This comes out to be what? 0.73 F is your new force, you can say. Now, A is your answer. Now, here, usually students ask, Sir, why have you equated the same thing for energy and force? What is energy equal to? What will the energy of the battery be equal to? Force into the distance traveled. Why do I say this? Because work done is equivalent to energy. What is the formula of energy? Energy is equals to force into distance. And this distance is being kept constant throughout the journey. So whatever you get as the answer of force, you can equate it to energy. 0.73 E is your answer. Let's further move ahead. Okay, let's see this question. The input power to a television is P in. The useful sound and light power emitted by the television is P out. What is the efficiency? P out over P in. A is your answer. 22's answer should be A. It is A. Let's further move ahead. Okay, let's read out this question. A man sits on a buggy that is pulled along by a wire attached to a kite. The wire is at an angle of 40 degrees to the horizontal and has a constant tension of 200 Newton. Perfect. The man and a buggy travel at a distance of 20 meters along a straight horizontal path, and the wire and the path of the buggy are in the same vertical plane. Perfect. What is the work done by the tension? We have to calculate work done by the tension. To calculate work done by the tension, first of all, work out this horizontal component of tension, that is 200 sine or 200 cos 40. Sorry, 200 cos 40. Perfect. Okay, what is the distance that you will travel? 20 meters. So force into distance. Force is what? 200 cos 40 multiplied by the distance, that is 20. 200 cos 40 into 20. This comes out to be 3064 joules. This is 3.1 kilojoules. B is your answer. The answer to 24 should be B, and B it is. Perfect. Let's see this. Researchers have developed a new type of filament lamp with an efficiency of 40%. Old type filament lamps have an efficiency of 5%. The two types of lamp produce the same useful output power. Perfect. What is the ratio of input power to input power of new lamp to the input power of old lamp? Perfect. Okay, so let's create two portions here, new lamps and old lamps. In the new lamp, your output power is P naught. Here also your output power is P naught. In the new lamp, you have an efficiency of 0.4 or 40%. In the old lamp, you have an efficiency of what? 5% or 0.05. Can we calculate the power input here? Yes, we can surely do that. Efficiency is equals to power output over power input. Efficiency is 0.4, power input is P naught. Power input comes out to be what? Power output divided by 0.4. Here also we can do the same. Power input is equals to what? Power output divided by 0.05. You have to calculate the input power of the new lamp divided by the input power of the old lamp. This is the input power of the new lamp divided by the input power of the old lamp. Let's just divide it now. P naught divided by 0.4 divided it by P naught 0.05. P naught gets cancelled out. 0.05 comes to the top. 1 over 8 is your answer. This is roughly equal to what? 0.13. A is your answer. 26 answer should be A. Perfect. Let's further move ahead. An object slides with constant velocity across a horizontal sheet of ice. Friction is negligible. A constant horizontal force of 2.1 Newton is then applied to the object as shown. Perfect. A short time after applying the force, the object reaches point X at a displacement of 4 meters from its position when the force was first applied. Perfect. What is the work done by the force on the object as it travels to point X? Okay, okay, okay. We have to see what is the work done by the force 2.1 Newton as it traveled towards X, that is 4 meters. Perfect. So, what can we do? We can break this distance down. We can calculate this horizontal component of the distance, that is 4 cosine 30. And now we can easily calculate work done. 2.1 into 4 cosine 30. This comes out to be what? 2.1 into 4 cosine 30. This is equals to what? This is equals to 7.3 joules. C is your answer. The answer to 28 is C. Perfectly fine. Let's further move ahead. A gas is contained inside a syringe as shown. The initial volume of the gas is 2 centimeter cube. Perfect. Atmospheric pressure is this. What is the work done by the gas on the atmosphere when the gas is heated and expands to a volume of 6 centimeter cube? Perfect. So first of all, the work done on the gas has a formula of what? Pressure into change in volume. What is your pressure? 101 kilopascal, 101 into 10 raised to the power of 3. What will your change in volume be? Your change in volume be 6 minus 2. And if you see the volume is in centimeter cube, you will have to convert it into meter cube. How will you do it? 10 raised to the power of minus 6 multiplied by 10 raised to the power of minus 6. Let's calculate the answer. 101 into 10 raised to the power of 3 into 4 into 10 raised to the power of minus 6. This comes out to be what? 0.404 joules. Now, obviously, I cannot see an answer in decimals. However, I can see this answer B. That is what? Millijoules. So if I take this decimal three places forward, 404 into 10 raised to the power of minus 3 joules. And this minus 3 can be replaced by what? Millijoules. B is your answer. The answer to 30 is B. Perfectly fine. Let's further move ahead. Okay, let's see this. A gas is contained in a cylinder by a movable piston. Perfect. The cylinder has a cross section of diameter 20 centimeter. Okay, so this is your diameter. Let's highlight it. Perfect. The pressure on the gas is 102 pascal and the piston is initially at 30 centimeter from the base. Perfect. The gas is heated, causing the piston to move up so that it is 35 centimeter from the base. The pressure of the gas remains constant. How much work does the gas do in moving the piston? Okay, so we have to calculate the work done by the gas. Work done by the gas is what? Pressure into change in volume. What is the pressure? 102. Okay, now how can you calculate the change in volume? Do you remember from O levels in IGCSE physics that volume is equals to what? Area into length, or you can say area into height. Here, just your height is changing. Your cross sectional area, that is this circle, is remaining constant. First of all, let's calculate the cross sectional area, that is the circle. We are given the diameter. Area will be equal to what? Pi du square over 4. Pi into what is d? 20 centimeter. 20 into 10 raised to the power of minus 2 to convert it into meters whole square divided by 4. 20 into 10 raised to the power of minus 2 whole square, okay, into pi divided by 4. The area comes out to be what? 0.0314 meter square. Now you have the area here. Okay, let's place it here 0.0314. What is left? Just the change in height. What was your initial height? H1. What was your final height? H2. Subtract both of them, multiply it, calculate the answer. 102, 0.0314 multiplied by the height 2, that is 35, multiply minus height 1 into 10 raised to the power of minus 2 to convert it into meters. So multiply it by 102, multiply 5, multiply by 10 minus 2. The answer comes out to be 0.16 joules. A is your answer. If I check in the marking scheme, 34 has an answer of A. Perfectly correct. Okay, let's see this question. A block of weight 80 Newton is pushed a distance of 60 centimeter up a slope inclined at 30 degrees to the horizontal. Perfect. There is a frictional force of 25 Newton between the block and the surface of the slope. Perfect. So there is a frictional force acting here that is of 25 Newton. Perfect. Between the block and the surface of the slope. Perfect. What is the work done against the gravitational force and the work done against the frictional force? The easier part is to calculate work done against the frictional force. The frictional force is 25 Newton, the distance traveled is 60 centimeter, work done against friction is pretty easy to calculate 25 into 0.6. This comes out to be what? 25 into zero point 0.6. This comes out to be 15. So answer A and C will get cancelled out. Perfect. What will be the work done against gravity? For that, you have to zoom in a bit. You have to zoom in a bit. And first of all, calculate the height. Calculate the height that we have dropped. Okay, what is the height that we have dropped? That is somewhat this thing. This thing. Can we calculate this orange line? Yes. This angle is 30 degrees. Okay. This hypotenuse is 60 centimeter. You have to calculate the perpendicular. So sine theta or sine 30 is equals to what? Perpendicular divided by hypotenuse, that is 60. 60 sine 30 is your perpendicular. Let's calculate that. 60 sine 30. This comes out to be what? Perpendicular is 30 centimeter. This is equals to 0.3 meters. The weight is 80 Newton. What will be the work done against gravity? Force of gravity, that is weight, multiplied by the distance, that is the vertical height. 80 multiplied by 0.3, this gives you an answer of 24. B will be your answer. Let me check it. 36 has an answer of B. Perfect. Train supplies coals to a power station. The table shows quantities describing the operation of the power station. Perfect. Which expression gives the efficiency of the power station? We have to calculate efficiency. Efficiency is what? Either power output over power input, or efficiency is energy output over energy input. Perfect. Let's see. Power station average output. Okay, this is watts. Perfect. Number of trains per day. Okay, N. Mass of coal on each train, that is M. Energy from one. Okay. And number of seconds in a day. Perfect, perfect, perfect. So what we can do is we can take this average power output, multiply it by S to calculate the energy output. And in the division, if I have to calculate the energy input, what will I do? Number of trains, uh, mass, and energy per coal. So NME in the denominator, PS in the numerator. A is your answer. Let me see. 39's answer should be A, and it is A. What have I done? I took the average power output, multiplied it by the number of seconds to calculate the energy output. How to calculate energy input? Take the number of trains per day multiplied by the mass of train on each coal multiplied by the energy from 1 kg. This is your energy input. A is your answer. Simple as that. Let's see this. A combined heat and power station generates electrical power and useful heat. The diagram shows the input and output for a combined, or you can say CHP station. What is the efficiency of the CHP station for producing useful power? Okay, we have to calculate the efficiency. How can we do that? Very, very easy. Very easy. What is the useful heating power? 160. What is the useful electric power? 100. What will be the total useful power? 260. Divided by what is the total power? 60 plus 160 plus 100. This comes out to be what? This comes out to be 320 into 100. This will be your efficiency. 260 divided by 320 into 100. This comes out to be what? 81.25. D is your answer. 41 has an answer of D. Perfectly fine. Let's further move ahead. Okay, let's see this. A constant force F acting on a car of mass M moves the car up a slope through a distance S at a constant velocity. The angle of slope to the horizontal is alpha. Perfect. What is the ratio of gravitational potential energy gained by the car divided by the work done by force F? Okay. What is the gravitational potential energy gained by the car? Again, we will utilize some trigonometry and calculate this height. Calculate this height. That is this height. We have to calculate this height, that is h. What is your hypotenuse? S. What is your angle? Alpha. Perfect. So, sine of alpha is equals to what? Hypotenuse divided by, sorry, perpendicular divided by hypotenuse. S sine alpha is equals to your height gain. What will be your gravitational potential energy gained by the car? Gravitational potential energy gained by the car will be equal to what? Gravitational potential energy. Are we given the mass? Yes. mg and the height, that is S sine alpha. Okay. What will be the work done by force F? F into S. So work done by force F is what? F into S. S and S cancel out. What is the actual ratio? mg sine alpha divided by F. Any answers like that? D is your answer. Perfect. And it is correct as well. Okay, let's see this. A horizontal cylinder of cross-sectional area A is fitted into a frictionless piston. Perfect. And contains air at pressure P. It is immersed in hot water and the length of the air column increases from X to Y. Perfect. The pressure P is constant. Which equation represents the work done by the trapped air during this process? Okay, we have to calculate the work done by the trapped air. Pressure into change in volume. Your pressure is P multiplied by area multiplied by change in height. What is the change in height or the change in length? From X to Y, what will be the change in length? Y minus X. C is your answer. Let me check it out as well. 48 should have an answer of C and it is C. Perfectly fine. Let's further move ahead. Let's see this. An engine transforms thermal energy into mechanical work. The engine takes in thermal energy Q in from the heat source and gives out thermal energy Q out to a heat sink, producing useful work W. Perfect. What is the efficiency of this engine? Perfect. You have to calculate the efficiency of this engine. Q in, that is the energy in the denominator, the useful work done in the numerator. 50's answer should be C and it is C. Let's further move ahead. Okay, let's read out this question. The diagram shows the design for a water wheel which drives a generator to produce electric power. The flow rate of mass is this. The generator supplies a current of this and a voltage of this. Perfect. Ignoring any changes in kinetic energy, what is the efficiency of the system? Perfect. How can we calculate the efficiency of the system? Input, energy output divided by energy input. Perfect. You can easily calculate the energy output. How? You are given the current and the voltage. Energy output will be equal to what? Current into voltage into time. Current is 32, voltage is 230, time is 1 second. How do I know that? Because we are talking about per unit mass. 20, 32 into 230. This comes out to be what? 7360 joules is your energy output. Okay. What will be your energy input? Energy input will be the change in gravitational potential energy, mgh. Your mass is 200. Your gravitational field strength is 9.81. Your height is 8. Perfect. 200 into 9.81 into 8. What does this come out to be? 15696 joules. Can you calculate the efficiency? Yes. 7360 divided by 15696 into 100%. Since you have to calculate it in percentages, your answer comes out to be 47%. Simple as that. A ball is projected into the air from horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the balls has kinetic energy E, Q, E, R, E, S, and E, T respectively. The heights above the ground of these 4 points are shown. Okay. Air resistance is negligible. What is the difference in kinetic energy is the smallest? Which difference in the kinetic energy is the smallest? Very, very, very easy. The points whose height difference will be the least will have the least difference in kinetic energy. So let's find out Q and S. So Q minus S, this will give you a height difference of what? 1.5 minus 1.6. I guess this will be the answer only. 1.5 minus 1.6, this is negative 0.1. I think A is the answer. Let me check. This is question 61. Yes, A is the answer. The points which have the least difference in height will have the least difference in velocity, because if you have the least difference in height, your kinetic energy is also pretty similar. So your difference in velocities or the difference in kinetic energies will be very negligible. Let's see this. The definition of which physical quantity is needed to drive this equation. Do you remember the derivation of this equation from the notes? We drive this equation using the formula of work done. D is your answer. Let me confirm it. 62 as an answer of D. Perfect. Okay, let's start with this question. A block is released from rest. Okay, so the initial velocity is 0 and slides a distance x along a straight slope. Perfect. The slope is an angle of theta to the horizontal. The slope is frictionless and air resistance is negligible. The acceleration of free fall is g, which expression gives the final speed of the block. We have to calculate the final speed of the block here. How will we do that? Pretty easy. First of all, to calculate the final speed, what can we do? We can calculate the loss in gravitational potential energy. What will be the loss in gravitational potential energy? Can I calculate this height, this thing, this blue height? Yep, I can surely calculate this height. How? The hypotenuse is x, angle is theta. I have to calculate this perpendicular. Sine theta is equals to perpendicular over hypotenuse. X sine theta is equals to your height. Okay. What will be your loss in gravitational potential energy? mgh. What is your mass? M. What is your g? Gravitational field. What is your h? X sine theta. Okay. This loss in gravitational potential energy will be equal to what? Kinetic energy gain. Why? Because there is no friction. There is no friction. Will be equal to gain in kinetic energy. Perfect. So let's write it here. mgx sine theta is equals to 1 upon 2 mv square. M cancel out. 2 goes to the other side. And if you take an under root, you will get your final velocity. Any options like that? B is your answer. Perfect. This question number is 63. The answer to 63 is B. Perfect. We are going good with 100% win rate today. Okay, let's see this question. Two trolleys are held together on a horizontal surface with a compressed spring between them. When they are released, the trolleys lose contact with the spring. The trolley of mass 2 kg moves towards the left at a final speed of 2 ms minus 1. How much elastic potential energy was stored in the spring? Now, this question is such a beautiful question because this involves momentum and energies together. So, initially, both the trolleys were at rest. So, the total momentum initially was what? Total momentum initially or total momentum before was what? Zero. What will be the total momentum after? The total momentum after is what? If this 2 kg is traveling towards the left with 2 ms minus 1, this 1 kg will be traveling towards the right with a velocity of x ms minus 1. Can we calculate that? Yes. If we apply law of conservation of momentum, momentum initial is equals to momentum final. What was the initial momentum? 0. What is the final momentum? 2 kg mass multiplied by negative 2. Why? Because this velocity is acting towards the left, and let's say the vectors acting towards the left are negative, the vectors acting towards the right are positive, plus 1 kg into the velocity, that is x. Perfect. This comes to the left hand side divided by 1. X is a velocity of 4 ms minus 1. Now, since there is no friction and since there is no heating, what can you do? You can sum up the kinetic energies of both the springs to calculate the elastic potential energy. The kinetic energy of 2 kg was what? Let's calculate it. 1 upon 2 into the mass, that is 2 into the velocity square. 2 cancel out. This comes out to be 4 joules. What is the kinetic energy of the 1 kg car? 1 upon 2 into the mass, that is 1 into the velocity, that is 4 square. This comes out to be 16 over 2, that is 8 joules. Take 8 joules, take 4 joules, add both of them, your answer comes out to be 12 joules is your answer. Simple. Let's further move ahead. Okay, objects with different masses are placed on a horizontal surface on a table. The objects are then raised to different heights above the table. The gain in gravitational potential energy of each object is same. Okay, so if I write the formula of gravitational potential energy is equals to mgh, this thing is getting constant for each of the system. Perfect. How will mass and height relate? How will mass and height relate? We also know that gravitational field strength is also constant. Okay. So if gravitational field strength is constant, gravitational potential energy is constant. Can I write something like this? Gravitational potential energy divided by mg is equals to h. Since both of these things are constant, I can replace it with what? A direct proportionality or an inverse proportionality sign. I will get a relationship like this. 1 over mass is inversely proportional to height, which is the graph of inverse proportionality A. So A is your answer. Which question is this? 69. Let me check. The answer to 69 is A. Perfect. Let's see this. A trolley of mass 600 kg is initially at point P on a slope. Perfect. At a height of 80 meter above the ground level. Perfect. As shown, the trolley is released from rest. Okay, so initial velocity 0 and moves along the slope, first coming to rest at point Q at a height of h above ground level. So here as well, the trolley is at rest. I think there will be friction here. The total distance between P and Q moved along is 1.5 kilometers. A constant resistive force of 300 Newton opposes the motion of the trolley as predicted. What is H? We have to calculate H. Perfect. So let's say this is position P. What will be the total energy at P? The total energy at P will only be the gravitational potential energy since the velocity is 0. mgh. What is the mass? Mass is 600 kg multiplied by g, that is 9.81, multiplied by height. That what will your gravitational potential energy come out to be? Yes, what will your gravitational potential energy come out to be? 600 into 9.81 into 80. This gives you an answer of what? 470,880 joules. Perfect. This is your total energy at P. Perfect. Now, what will be the total energy at Q? The total energy at Q will be a sum of what? Work done against friction or resistive forces plus gravitational potential energy at Q, since the velocity at Q is also 0. What will be the work done against friction? 300 into 1.5 into 10 raised to the power of 3, since we have kilometers, plus gravitational potential energy at Q, that is what? M. What is the M? 600 into G, that is 9.81 into H. So let's calculate it. 300 into 1.5 into 10 raised to the power of 3. This gives you an answer of what? 450 and 30 joules. Oh, not the unit now. Plus 600 into 9.81. This gives you the value of H, that is 5886H. Perfect. This is the total energy at Q. Now, according to law of conservation of energy, you know that the total energy throughout the system remains same. Both these green values are actually same. So let's equate both of them. Let's equate both of them. 470,880 is equals to 450,000 plus 5886H. Okay. 470,880 minus 450,000 divided by 5886. H comes out to be what? H is 3.5 meters. The answer 274 should be A, and in the marking scheme it is A. Very good. Very good. A ball is dropped from rest and falls towards the ground. Perfect. Air resistance is negligible, which graph shows the variation with the speed of the height of the ball. Okay. So as the ball is getting dropped, gravitational potential energy is getting converted into kinetic energy. Okay, what is the gravitational potential energy? Mgh. What is the kinetic energy? 1 upon 2 mv square. M and m gets cancelled out. You have to plot h on the y-axis. So let's take everything to the other side. H is equals to uh, v. You can put v square here, and this will become 1 over 2g. Perfect. 1 over 2g is a constant, so you can replace it with a direct proportionality sign. This is on the y-axis, this is on the x-axis. What type of a graph do you expect? A quadratic curve. D is your answer. The answer to 77 is D, and yes, it is. This difficult question as well. Initially, four identical uniform blocks, each of mass m and thickness h, are spread on a table. The acceleration of free fall is g. How much work is done on the blocks in stacking them on top of one another? Okay. So we have to stack them on top of one another in this scenario. Things in a proper way. If you see, you don't need to move block 1. This block in green doesn't need to be moved. Why? Because this is already at the correct place. However, you would need to lift this block in yellow. You will need to lift this block in yellow. And what will be the gain in gravitational potential energy of this block in yellow? You will have to lift it up and place it here. The gain in gravitational potential energy will be what? 1 second. Let me zoom in a bit. The gain in gravitational potential energy of the first block will be what? Gain in gravitational potential energy of the first block will be what? The mass is m, gravitational field strength is g, height is h. Okay. You will also need to lift this block as well. And this block will be stacked up on the top of the second block like this. What will be the gain in gravitational potential energy of this second block? mg, and this time the height is 2h. This is the pink one, and the middle one is the yellow one. Let me highlight that as well. Yep. Let's move on to the fourth block. The fourth block is this one. Perfect. In order to lift this or place this according to the stack, you will need a gain in gravitational potential energy of what? mg and 3h. So this is your blue block. What is the total gain in gravitational potential energy in stacking them over one another? 3 mgh plus 2 mgh plus 1 mgh. The answer comes out to be 6 mgh. The answer is B. Let me see. This question is 80. The answer to 80 should be B. Perfect. Yes, it is B. This looks like an ice lolly. Chalo, let's further move ahead. Let's see this. A steel ball is falling at a constant speed in oil. Which graph shows the variation with time of the gravitational potential energy and the kinetic energy of the ball? Okay. If you are falling at constant speed, your kinetic energy is going to remain constant. Neither C nor D will be your options. Perfect. And as you are falling, your gravitational potential energy is decreasing. What will be your answer here? Your answer will be B. Your gravitational potential energy decreases linearly. B is your answer. Perfect. Let's see this question. An object is thrown into the air. Perfect. Which graph shows the gravitational potential energy of the object varies with height of the object? We have to tell the graph of gravitational potential energy with the height of the object above the ground. Obviously, if you have studied the formula of gravitational potential energy is equals to mgh. As height increases, the gravitational potential energy will increase. A is your answer. Perfect. Okay, let's see this. A boat moves at a constant velocity v through still water. A constant drag force F acts on the boat. What is the power used by the boat to move the water? Power is equals to force into velocity. B is your answer. Perfect. Let's see this. A variable force is applied to ensure a constant power is supplied to a train. Which graph shows the variation of force with velocity? Okay, if power is equals to Fv and power becomes constant, So let's bring force to the downside. You can replace this power with a proportionality sign. 1 over F is inversely proportional to velocity. A is your answer to 102 should be A. Let's check it out in the marking scheme. Yes, the answer to 102 is A. Let's further move ahead to the next question. Okay, let's read out this question. An escalator is 60-meter long and lifts passengers through a vertical height of 30-meter as shown. Perfect. To drive the escalator against the forces of friction when there are no passengers, we require a power of 2 kilowatts. The escalator is used by passengers of average mass 60 kg and power to overcome friction remains constant. Perfect. How much power is required to drive the escalator when 20 passengers are traveling at a speed of 0.7 ms minus 2? First and foremost, power has a formula of what? Energy over time. What is the energy when passengers move towards the top? What is the energy gain when the passenger moves towards the top? Gravitational potential energy. So mgh over time. Mass is pretty easy to calculate. 20 passengers, each has a mass of 60 kg. G is 9.81. Now, what is the height? Height is 30. Perfect. Now, the time. How will you calculate the time? That's interesting. How will you calculate the time? The passengers are moving 60 meters diagonally with a speed of 0.7 ms minus 1. Can you calculate the time? Yes, time is equal to distance over speed. 60 over 0.75. 60 divided by 0.75. This comes out to be what? Let's calculate it. 80. So the time is 80 seconds. Your power comes out to be 4.4 kilowatts. But if you give this answer, you would score a 0 because there is 2 kilowatts of power utilized to do work done against friction. So 2 kilowatt added here. The final power comes out to be 6.4 kilowatts. B is your answer. This marks the end of work energy power MCQs. If you have any questions, you may ask in the chat.